Hello everyone. Hi, this is Dr. Tithi Banerjee, Assistant Professor of Department of Civil Engineering, Swami Vivekananda Institute of Science and Technology. So students, today I'll be delivering today I'll be delivering lecture on few properties of a mineral, that is physical properties. In the last two classes I have already delivered lectures on the majority of the physical properties of the mineral, but few has not been addressed yet. Today I will address all those properties. So let's start the class. So today I will discuss about fracture. Fracture is a very important property of a mineral. So what is fracture? Fracture is the way a mineral breaks unevenly, not with smooth or flat or planar surfaces. So, what is the difference between cleavage and fracture? Fracture in a mineral occurs when a mineral breaks in a random, uneven pattern without following any specific cleavage planes. This happens when the mineral's internal structure is equally strong in all directions, meaning there are no planes of weakness to facilitate smooth breaking. Fracture can also occur due to stress exceeding the mineral strength, leading to a loss of cohesion. So, for generation of cleavage, we all know that we need a definite weaker plane. But for generation of fracture, no definite weaker plane is required for breakdown. A mineral can, during fracturing, a mineral or material breaks down along random non-planar surfaces. Unlike cleavage planes, this happens because, as I have told earlier, this happens because the mineral's cohesive forces are similar in all directions. That means no specific planes will be preferentially weakened. Fracture can be caused by stress exceeding the mineral strength, leading to a loss of cohesion along a weaker planes. Fracture can also result from tensile or shear stresses also. So, as a civil engineer, why we will study fracture? As I have discussed earlier also, that civil engineers should know that where a building or any kind of construction can be conducted. If we doesn't know the weaker planes or the fracture planes of a mineral or of a rock, then it will be a big blunder, because without knowing properly the cleavage or fracture planes, if we construct anything on a weaker plane of a rock or a mineral, then the construction can collapse very easily. So that's why the study of fracture is also very important. So there are several kind of fractures, just like cleavage. A specific pattern of fracture is known as conchoidal fractures or conchoidal fracture. It is a very irregular fracture, very irregular fracture that can be caused in a that can be identified in a broken rock, broken stone, broken mineral, a curved shell, or a broken glass. Anything it can be happen. Very irregular fracture planes. Other fractures patterns are fibrous fracture. That is, as I have told in my previous class, a typical mineral, that is gypsum, which exhibit two sets of cleavage of 90 degree, but its fracture is fibrous. Okay. Another mineral which exhibit fibrous fracture, that is asbestos. There are also more fracture patterns. Irregular or uneven fracture shows no definite pattern, that is hematite or magnetite. In the previous class I have told that Hematite and magnetite are ore mineral that can be identified by its color or streak. Sure. So now I will go move to the another important properties, that is crystal shape. So shape defines nothing but a definite physical form of a mineral. So there is several crystal shape. Typical mineral can be identified by that typical shape. That is pyrite. That is also a ore mineral. That shape is cubic. Halite, rock salt. That the shape of the halite or rock salt is also cubic in pattern. Galena also exhibit cubic shape. So these definite shapes of mineral is also important and distinct identified properties. Hexagonal, if a mineral have 6 faces, then the mineral can be identified at hexagonal. Suppose quartz corundum, it exhibits hexagonal shape in pattern. There are more crystal shapes also, that is rhombic, shaped like a parallelogram or a rhombohedral. Calcite shows rhombohedral shape. So shape can also be a distinctive identifying properties of a mineral. Now, if a mineral doesn't have a regular shape, like I have told, majority of the ore mineral doesn't exhibit a proper shape. But how we will identify it? We will identify it by its other properties. That is hematite, magnetite, its streak will be different, its color will be different. So they will not exhibit prominent cleavage surface also. But color, streak will be their identified physical properties. Another important properties is effervescence. Effervescence is a nothing but a acid test. When any acid, any kind of acid, HCl, that is hydrochloric acid, sulfuric acid, that is H2SO4, is added to calcium carbonate, it causes bubbling as carbon dioxide is released. So, if we have to identify calcite, then we can put a little drop of acid on it to find whether it is generating any effervescence or not. Because in field or in site area, calcite is rhombohedral in shape and color is white, but same with feldspar also, it also sometimes shows white in color and it also have a parallelogram in shape. So to differentiate between feldspar and calcite, effervescence will be our identifying properties. Another important property is double refraction. Now it is a very interesting thing. What is double refraction? We all know that when a light passes through when a light passes through a substance or material, it can be the light can get refracted, reflected, or the light can get completely absorbed. Okay, if the light can get totally reflected, then the mineral can be identified as transparent mineral. And when the light is partially reflected and partially absorbed, then the mineral can be identified as translucent. In case of translucent mineral, the light get some amount of light get reflected and some amount of light get refracted. Okay, so in case of refraction, majority of the mineral, if we consider refraction as identifying properties, majority of the mineral exhibit these properties. Now what is double refraction? Because calcite have a very interesting phenomenon. We all know that calcite exhibit rhomboidal cleavage, and the because of the orientation of the cleavage, when light passes through a calcite, then the light can get doubly refracted, one by the calcite mineral by itself, another by the cleavage plane. Okay, so calcite sometimes exhibit double refraction, because there is also another reason, because calcite exhibit zoning also. When zoning is occur when there is heterogeneous element is there, when heterogeneous elements are there in a mineral, then zoning does occur. Because of zoning also, calcite get doubly refracted. Okay, so double refraction is also can also define as a very important property. Magnetism also can be tested in field or in hand specimen by using a magnet. So the hematite, magnetite, all are magnetic minerals, because I already discussed that both these hematite and magnetites are ore minerals. So they are ore minerals of what? Ore minerals of iron. So because of the presence of iron, both the ore minerals can get attracted by a magnet. So by using a magnet, it can also be identified that whether the mineral is magnetic or non-magnetic. Another property is fluorescence, property where the mineral glows under ultraviolet light, that is fluorite and calcite. So this is also an important property. There is the photographs of calcite and fluorite. How does it look like ultraviolet light? Because all minerals will not glow in ultraviolet light. Many of the minerals will they will just absorb the ultraviolet ray. These minerals can get reflected by ultraviolet light. Now another important property comes radioactivity. What is radioactivity? The minerals are, or how can I explain what are radioactive minerals? Radioactivity is nothing but the property which a mineral shows. What is that? Minerals that contain radioactive isotopes such as uranium and thorium are known as radioactive minerals. So such as example, for example, zircon and monazite both are radioactive minerals because they contain uranium, thorium and potassium. Okay. Another important property is specific property. In one sentence, if I say that specific gravity, what is specific gravity or density? That it is the mass of a unit volume of a mineral. So it clearly defines the heaviness of a mineral as compared to water. It's almost similar to density. For example, pyrite has a specific gravity or density of 5, whether water has a density of 1. Okay, so sorry I sorry so specific gravity of water is 1, and compared to that pyrite has a specific gravity of 5. Now why specific gravity is an important property? Because it in hand specimen also, specific gravity will help us to know whether the minerals is denser or lighter. So several minerals have several specific gravity. Suppose pyrite has a specific gravity of 5, but gold both look like same, but pyrite is more denser and heavier. So specific gravity can also be an important identifying physical properties of a mineral. So those are all those physical properties I have discussed in those lectures. So in the next lectures I will be describing about the optical properties.